Welcome to this session on regular expressions. This is part of the course Natural Language Processing 1. In order to know whether a word like introspection was spelled in a book correctly, one had to go through every time and every line on every page. A proofreader had to struggle, spending a lot of time searching for the word. But now it has become so easy with the search engines. We can search for a word or a phrase in any form, with capital letters, without capital letters, small letters, a combination of them, with numerals in them, and so on. The most useful concept in building such a search engines is regular expressions. We are going to learn about regular expressions in this video. What is a regular expression? A regular expression is defined as a pattern that defines a string or portion thereof. That is, if you have a word like introspection, if you are looking at the string intro, I-N-T-R-O, string is a list of characters. So if you are looking for the string I-N-T-R-O, that is a regular expression, right? You need a regular expression for that pattern. So when comparing this pattern, whatever pattern which you are looking at, which you are trying to call it a regular expression, against a string, then it either returns true or false, right? If true, it will return something. It depends on the function which you are going to use it for. So the return value will depend on the specific function and its attributes. How can we search for any of these strings? When I say string, what is a string? A string is a sequence of symbols. Symbols may include characters meaning alphabet, numerals, or other symbols too. So for the purpose of most text-based search techniques, a string is any sequence of alphanumeric characters. That is letters, numbers, spaces, tabs, punctuation, and so on. A space is also a character, like any other. So, if you are trying to define a regular expression formally, it's an algebraic notation because it's not just characters, right? So, it is an algebraic notation for characterizing a set of strings. And they can be used to specify search strings as well as to define a language in a formal way. And regular expressions are used for searching text in Unix, Perl, Python, Emacs, including applications like Microsoft Word, WordPerfect, Excel, right? In all of them. So many regular expression features exist in various web search engines, either Google or Yahoo or any other search engine. So regular expression is a very important theoretical tool in computer science and linguistics. Let's see some of the regular expression testers. I have given you a list of regular expression testers. You can go to these websites and test your regular expressions, right? So a regular expression now is a formula for characterizing patterns of strings. A string is sequence of characters, right? And a regular expression consists of alphanumeric characters, and they are used in several applications. That's what we know till now, but we'll go into details now. I've given you some of the regular expression patterns here. pattern here, a regular expression pattern, is woodchucks. Woodchucks. How is it written? It's written in between slashes, right? There's a slash here, there's a slash there. So woodchucks. Now this is a regular expression. What will it match with? It will match with woodchucks. So for example, if you have a text like this, interesting links to woodchucks and lemurs, this regular expression will match with this, right? Similarly, you have another regular expression, a, between two slashes. So whatever you put in between slashes, that is your regular expression. So this a will match with a here, it will match with a here, it may match with a there, etc. Right? But it's matching with the first one now. Or if you have something like this, Ali says, comma. This again a regular expression. You see there's a capital letter here, there's a comma here, right? We have already seen that a regular expression may contain alphanumeric characters and punctuation too, and spaces are also characters. So there's a space here, there's a comma here, so everything is one regular expression, and it matches with this, right? It doesn't match with the quotes here, it only matches with Ali says, comma. Another RE is book, so it matches with book. There's no S doesn't match. And you have a punctuation marker here, exclamatory mark, and that matches with that. Okay. So what we understand here is a regular expression is case sensitive. That is, if you give in the regular expression a small case, then it matches with only small case. If it is a capital letter, and it matches with capital letter. So for example, if you have the pattern woodchuck, which is given here within slashes, it has no capital letters, so it will match with only a word with small letters. It will not match with the string woodchuck here, which has a capital letter W, right? So the string of characters inside the braces specified. So woodchuck will not match with capital woodchuck here. Now let's look at the next one, which is a disjunction. So what we need is, now we want to check woodchuck whether it is capital letter or small letter. How do you do that? Then we have an option here. If you keep two letters in, or two characters in square brackets, it means either the first one or the second one here. That means what we are saying here is there is a disjunction between small letter W and capital W. So either this or this, and the rest of the letters. So if this is your regular expression, then this will match with both the words woodchuck with a small letter and woodchuck with a capital letter. So there is a disjunction operation here, right? Whenever you use square brackets, that represents disjunction. So you have more examples here, right? So here is A, B, C in brackets, so it means either A or B or C, right? So it will match with any of those things. And in the example here, there is no A, B, C, except here where there is A, so it matches with A, right? Or if you put 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 in square brackets as a regular expression, then it means any digit 1 to 0, or 1 to 0, or 0 to 9, whatever you say. So if you have an expression like plenty of 7 or 5, it will match with 7, right? It's matching with the first one now, of course. Okay, so what we understand here is whatever we use in square brackets shows disjunction. Now let's look at some of the classes or sets which we use in regular expressions. So when you have within square brackets 0 to 9, that means we are giving a range. Similarly, A to F, small a to small f. So whatever is in between is also covered. So we don't need to mention 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 or A, B, C, D, E, F, right? We can just say A hyphen F, which shows the range between A and F, right? Similarly, this range, it includes the end characters, both A and F, and 0 and 9. So this is range. The way we mention a range is by using a hyphen. Of course, we need to put them in slashes. Then only it becomes, then only they become regular expressions. There are some more shorthand for character classes. So you can use /D, which matches a single character, that is a digit. So D is a digit. Similarly, if you say /W, it matches with a word character, where alphanumerical scores and alphanumeric characters and underscores together. If you say only /S, that it matches with white space, and if you say /D, capital D, small d and capital D, then it means not /D. This is a caret. Caret represents negation here, right? That means not digital. That means it doesn't match with, if you use /D, it doesn't mention digits. That means it will match with all alphabetical or alphanumerical. That means it is equal to /W possibly. Similarly, if you use /W, it actually means not /W. And also you can say /S can be negated, can be equivalent to, can be mentioned as not /S, small s, right? So you see in this, you can mention range by using a hyphen. You can mention digital characters by using /D. You can mention alphanumeric characters by /W. You can use /S for white space character, and you have a caret we use for negating the whatever comes next, whatever character comes next. Okay. Next, look at this. We have something optional. What do you mean by that? So we have seen that square brackets mean disjunction, this or that. But if we want to check a word like woodchucks, where you have plural s, and woodchuck with a singular, we want both plural woodchuck and singular, that is s is optional. How do we mention that, right? How do we mention that? If you use square brackets are used only for characters, disjunction of characters, but not the entire string. How do we go about it now? We use a question mark preceding the token in the regular expression, right? We use a question mark to mean optionality. How is it used? It is used after the character or after the regular expression which we want to be optional. So for example, if you have two spellings of the word color, color has two spellings. One is British, C-O-L-O-U-R, and American, C-O-L-O-R. So we want to check whether the word color, whatever be the spelling, whether it is COLOUR or COLOR, exist in the given text. Then if we have a question mark after U, it means this U is optional. And if you use this as a regular expression, we can have all the words which whether they are with U or without U, right, from the text. This is a token. So you can make several token options by grouping them together using round brackets, a parenthesis, what we call parenthesis, and placing the question mark after the closing bracket. So here it is only the character which is optional, but not one character, but you want a string of characters. How do you do that? Then what you need to is, you need to group the characters which you want to make it optional. For example, in November, you want to make Ember as optional. So keep Ember, EMBER, within brackets and use a question mark there. Then this will match, this regular expression will match with Nov, that is NOV, and also November. So you can write a regular expression that matches many alternatives now by including the optional question mark. Right? It's very useful. It is a very useful operator here in regular expression. So you can say Feb or February 23rd or 23 matches with February 23rd or February 23 or February 23rd or February 23. So 4 kinds of strings can be obtained just with one string which you can give here, right, by using question mark. So what does question mark mean? Question mark means 0 or 1 instance of the previous character or group of characters. The question mark represents 0 or 1 instance of the previous character. That is, it shows the optionality of the previous character. But that's not enough for us. Sometimes we need repetition of a particular character. That is, a particular character may appear many times. So if you consider language of sheep, that is Ba, which consists of B and A, but not necessarily one A. It can be BAA, 2 A's, maybe longer. That is, if it is Ba, maybe B, 3 A's, B, A, 4 A's, 5 A's, and it can be longer. So there is a repetition of the letter A. We need some device to take care of such instances. So if you want a regular expression for language of sheep, then we need to look for something called Kleene star. Kleene star is nothing but an asterisk mark. It is after the person who has invented the Kleene star, right? How to use the star in identifying 0 or more occurrence of particular character. So Kleene star means 0 or more occurrence of the immediately previous character or regular expression. So A star means any string of 0 or more A's. So this will match. When I say A star, it will match with A. It will also match with A. And it will also match with a string like OFF, MINOR. There is no A in it. There is no A in it. But still it matches, because when you say A Kleene star, it means there is no A or there is a A. Right? So it matches with this too. So if you want to really match the language of sheep, there should be at least one A, B-A. It cannot be just B. So the expression we need, regular expression, is which consists of A star. That means there should be a single A first, and then there can be an A or may not be, there may not be an A, or maybe a string of A's. Right? So the regular expression for matching one or more A is A Kleene star, meaning one followed by 0 or more A's. More complex patterns can also be repeated. That is, it's not just one single A. Like for example, if you put AB in brackets, remember square brackets means disjunction. So A or B. Then star, that means you can have any number of A's, you can have any number of B's. Okay, either 0 A's, 0 B's, or more A's and more B's is also possible. So this is how you are creating a complex pattern using your disjunction and a clean star. So the regular expression for an integer consists of string of digits 0 to 9, right? It is not only 0 to 9 digits, but when you are looking at an integer, it can be 10, 1, 0, 11, 1, 1, or 94, 9, 4, or 934, 9, 3, 4. The first one is a digit, and then rest are also digits. The rest are repeated. So what we can do is a regular expression for an integer can be 0 to 9, 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7, 8 or 9, and again 0 to 9, any of them with clean star. That means the second one is optional, right? You can get now an integer up to 99. Not in 99, in fact, because clean star represents not 1 or more, right? 0 or more, it can be repeated any number of times. So we get an integer, right? But we don't use 0 to 9 this. Why? Because when you use clean star here, without this, so there can be something without any number, any digit at all. So we cannot get. One digit has to be there when you are looking at as an integer, right? Okay, let's go further. We have another controller here, Cleany Plus. Cleany Plus, where do we use it? Sometimes it is annoying to have to write the regular expression twice. You don't want to write the same thing twice. There is a shorter way to specify it. At least one of some character. That is the clean plus. Cleany plus says 1 or more. Right? While cleany star said 0 or more, cleany plus is 1 or more of the previous character. So the expression 0 to 9, 0, 1 or 2 disjunction, plus it means this will have 1 time or more. That means this is a simpler way of mentioning your integer now, right? So there are two ways now of mentioning an integer, either using cleany star but twice you mention 0 to 9, or using cleany plus but only once you mention. Similarly, there are two ways of specifying sheep language. You can do this BAA star, that means this A is repeated, or you can just say BAA plus, that means one or more A's automatically occurs here. So look at the use of cleany plus now. Let's look at, these are called operators. Whatever we have seen now, the optional question mark which we have seen, the asterisk, the cleany star and the cleany plus, they are called operators. Now we are using the operators. This is 0 I, 0 or 1, right? When you say woodchucks question mark, you can have S or without S. So it can match woodchuck, woodchucks. Similarly, color with question mark after U, it can match with COLOR or COLOUR. When you use cleany star, it is 0 or more. So OO star H may mean O, right? Or O or OH, right? One O is missing here, you can see. Or if you use cleany plus, 1 or more, so you can say O plus H, O cleany star H, O, O, and O. So whatever operator you use, that that is related to the immediately preceding character or regular expression. Right? That's your operator. In addition to this, we have a wildcard. Wildcard is your period, the stop, full stop which you use. So if you use a regular expression like BEG, period, and N, this period can match with I, match with A, it can match with U. Right? Any character between BEG and N is specified by the wild character period here. Right? These are all operators. We have already seen negation, but we are going to go into a bit detail now. We said a caret is used for negation. Caret is used for negation. So if I use caret A, that means not A. It can be anything else, any other character. Right? So this matches with any single character except A. You can use caret in this case too. You say caret and A to Z, the range, then not any capital letter, not any of the uppercase alphabet. That's what this means. So when you have O, Y, F, N, P, R, I, P, T, C, H, I, K, this will match with Y but not with anything else. Similarly, if you say capital S, not capital S or small s, that means neither capital S nor small s. Similarly, caret slash dot, that means not a period. Here we are not using period as an operator. We are using it as period. That's why we are using slash. Look at the use of slash here. When you use a slash inside these square brackets, we are using it to specify that whatever occurs is not an operator. Now, similarly, if you use E and caret, it means either E or caret. Here, the caret is not negative. It is not negation because there is nothing which follows it. So, it is not negating. It is occurring only as a caret. Or if you use A caret B, it matches with A caret B pattern. Let's look at some anchors. What are anchors? Anchors are special characters that relate the regular expression to a particular position in a string. The two anchors which we are using here are caret sign and then dollar. Caret, we have already seen that it represents negation. Right? Now, it has a different meaning too. It can also mean initially, that is start of a line. So if I use like this, it can mean that any character A to Z is in the beginning. So R or P. Right? Or if I say caret and in brackets caret A to Z, that means not alphabet, not capital letters, but start of the line. So it matches with something like this, which can be anything, not capital letters, right? Or really kind of thing. Similarly, when you use dollar sign, it means end of line. So when I say slash period and dollar, it means the period is at the end of the line. There is nothing which follows the period. Or if I put period and dollar sign, it means it matches with dollar, it matches with nothing at the end. Right? You have a question mark which can match with that. Okay. What we see here is anchor, like negation with the caret sign, is used not only for negation and the meaning of caret, but also can be used to start of the line. Dollar sign is used to indicate the end of line. You also have something like slash B and slash capital B. Slash B shows a boundary. So if I say slash B ON /b, that means between on occurs with a boundary. That means nothing, there cannot be any other character before it or after it. So it can match with something like on my way. Right? There is no character before on or after on. But if I use a capital B, it shows non-boundary. So you can see capital B here, so non-boundary, but there's a boundary. So it matches with automaton or automation, on. Before on you have T, and after on there's nothing. So smash capital B, that's why it's not a boundary. Small b later, so it is a boundary. So anchors are special characters which indicate the position of the string, beginning, at end, or between boundaries. Now these, what you've seen, periods, etc., they are meta characters because we are using them for representing other things in regular expressions. So when you use a period dot, if it matches any one character, right, its dot is a meta character. Question mark, right, is meta characters. Cleany star is also meta character. Cleany plus is a caret, dollar, even square brackets, which shows the class, character class. All of them are meta characters. That is, we are not using them as characters like period as period, or question mark as question mark, or star as a star, plus or a plus, right? Similar to this, we are giving them newer meanings, so they are meta characters. So if you have literal characters A to Z, capital letters and small letters, and 0 to 9, these are literal characters, right? But meta characters are square brackets, backslash, caret, dollar sign, period, vertical pipe. Pipe is used later, we'll show it as a disjunction, question mark, cleany star, cleany plus, round brackets or parenthesis. Right? If you want to use any of these characters as a literal in a regex, you need to escape them. How do you escape them? By using a backslash. We have already seen to mean a period we used backslash. So 1 plus 1 equal to 2. The correct regular expression is 1 backslash plus 1, because this plus is not used as a meta character, it is used as a literal character, right? In order to escape, we use backslash. Now coming to the meta character pipe, we have already seen disjunction earlier. Disjunction, we put it in square brackets. When you put something in square brackets, whatever is there in the square brackets, they are optional. So square brackets, within square brackets, if you use AB, it means A or B. But we do not want optionality or disjunction between characters. We want disjunction between strings. How do you have that? So that is, if you have yours and mine, these are two different words. One string is yours and the other string is mine. We want a disjunction between these two. If you put square brackets between yours and mine, you use square brackets and you say yours and mine, then what happens? It can be Y or O or U or R or S or M or I, N or E. We do not want that. We want yours or mine. So to show that this string is different from this string, the optionality between these two strings, then we use a pipe. That is a straight line kind of thing. So if you use pipe, it means either. It is either yours or mine. That's the disjunction. So disjunction pipe shows disjunction between strings. Disjunction square brackets means disjunction between characters. So if you have a word, if you want to identify word like guppy and guppies, that means you want a distinction between Y and IES. Then you can say gup and group them, right? In the group, you say either this string has only one character, or this string which has 3 characters. So this regular expression, gup in parenthesis Y, pipe and IES, will match with any of these two, guppy or guppies. We have seen parentheses, square brackets, counters like star, cleany plus, cleany star and question mark. We have also seen anchors, right? Caret, dollars, etc. And also disjunction pipe. If all of them occur, how do they function? They function in a particular way. That means there is a hierarchy among them, right? The hierarchy goes like this. This as the first one, and the next these occur, and next this, and next this applies. The hierarchy goes down like that. So parenthesis is taken first. That is grouping. Grouping is done first. Then counters will work, right? Then sequences, the anchors, right? Whether initial or final, etc. And at the end, the disjunction. Disjunction has to occur at the end because they work on strings, right? So that's how the precedence hierarchy, operator precedence hierarchy applies. And remember, regular expressions are greedy. So they always try to match with the largest string they can. They do not match with small strings. They always match with the large ones. Suppose we want to match any string which is enclosed by the HTML tags for boldface. In HTML is used to represent your pages, web pages, right? HTML as a language. And you have to represent bold in HTML, we use in angular brackets capital B, and you begin with this and you end with the string. So whatever occurs between these two is boldfaced. So if you are using a regular expression and trying to find out what is boldfaced, what is not boldfaced, etc., then if you are using this B and then a period, star, and the end of boldface, this would successfully match with this. Okay, this will match with this because period is a wildcard, so it can match with anything. It will match with important. It will also match with important like this, and also urgent, right? It is not the word important, it's a different word now. So since this sub pattern will happily match with all characters from the end of important to the end of urgent, okay, it will match with both end of urgent. One way of ensuring that we only look at matched pairs of tags would be to use expressions. So you have to use an expression so that you can really get a real match. So if you are using something like this, where the character class matches anything other than a left angle bracket. Let's take an example. Look at an example. Now if you want to find out all the instances of the word the in a text, the text is this: the recent attempt by the police to retain their current rates of pay has not gathered much favor with the Southern theology or other factors or factions of the group of 5. There's a the here, there is a the here, there's also another the here. And if you are using a simple regular expression like this, it will match with only what? It will match with the here, and it will also match with the here. It will also match with the here with between other. It will also match with the here, but it will not match with capital T. which is actual the, right? It will match, it's matching with correct the, and it's also matching with others which are not correct, and it's avoiding what it has to match. So this is not correct. There are errors when you're using this match. So we need to reduce the errors. How do we reduce the errors? One is to reduce errors which are caused by not matching with what it is supposed to match. That means we need a capital T. So what we do is, now we give a disjunction, square brackets, small t and capital T and HE. This will definitely give you capital the and the. So we have avoided the error that which the regular expression is to match, which it hasn't matched with, right? That we have reduced. But still this matches with the in there, the in gathered, the in other, the in southern. It is not supposed to match with this. In order to reduce that, we need to say no, the word the has a boundary before and after. So if you use boundaries, it will correctly match with the and the, right? It will match with this and this. But still, we have to clearly state a different way of doing this, because it will may match this to the underscore, right? Not as a boundary. So what we have to do is, now we may say, okay, not A to Z capitals, then the, then not this. Then it will definitely take care of the and the. Still, we need to modify it to get not in the beginning, in the beginning, that is it, right? In the beginning, or not these characters. Then you have optionality, HE, then not these characters. Okay, this will give you the exact match of the. You'll get only 2 instances of the here, not the ones which are not required, right? So you have to be very careful when you are writing your regular expression, how to avoid the errors. That's what you are learning here. Let's take a look at a more complex regex example. For example, if you want to find out regular expression for prices, rupees 0 to 9 plus, that means it can be 0 rupees, 1 to 99 rupees, or more than that too, because it's a clean plus. But this deals with rupees but not paise, fraction of rupees, right? In order to deal with paise, what we need to say is, okay, rupees plus, and then we are using the escape character, then dot is what says point, decimal, and then the paise. So this will definitely match with 1.99. It will not allow $1.99 because not at a boundary road. Now this will not correctly give you again. It will give you the paise, right? But when there is no paise at all, what will you get? You have to say 199.00. If you want to avoid that also, then you can say there's a boundary, rupees 0 to 1, 0 to 9 plus, then escape character, then dot 00 is this, and question mark. Question mark is 0 or 1, optional. So that means this character, this whatever we are representing for paise is optional, and then is a boundary. So this regular expression will match not only with just rupees but also rupees and paise together, right? So this is your regular expression to find out rupee with paise rupees. You have some more operators. There are advanced operators. Look at them. You have n in curly brackets. This means exactly n occurrence of the previous character or expression. That means if you give 2 and there's a character a and 2, that means a occurs only 2 times. Till now we have given clean star to represent 0 or more, but here we want exact number, 2 times, 3 times, 4 times, 5 times. Then we use n occurrences. You can also represent in a different way, n comma m. That means n to m occurrences. That means if you say 3 to 5, that means you'll find 3 times, 4 times and 5 times. So if you say a curly brackets 3 comma 5, that means it can function, it can give you match with 3a's, 4a's and 5a's strings in the text. Or if you say n comma nothing, at least n occurrences of the previous character expression. At least, that's what it means. So for example, you say a slash dot 24 in curly brackets and z. What we are saying is a should be followed by 24 dots and then z. So this regular expression matches with a, 24 dots and z, right? So curly brackets is giving you an option of telling how many occurrences we need of a particular character or string or expression. One of the very important concept is substitution, which is used in Perl, Python, Unix, in most of the languages, right? So you have a regular expression 1 which has to be substituted with regular expression 2, right? This 2 substitutes expression 1. So if you want to substitute every word which is CYLOUR with CYLOR, you can use this. We are using Perl language here, right? Or you can say /g, that means as many times as possible. You can give 2, that means it will substitute twice. If you say 3, it will substitute 3 times. And if you use I, it will match with case sensitive, right? Case insensitive. Any name, that means color can be capital, small, or mixture. With everything, it will substitute with CYLOR, right? So that is substitution of particular expression with another expression. But you can also substitute a particular string within another string. So if you have the XER, they were, the XER, they will be. This X and this X have to be substituted. And this is the first X and this is the second X. So you have to constrain the two X's to be the same string, right? How do you constrain? You can constrain them by using numbered memories or registers. How do we use? We use $1 or $2, $3, $4. Each one is a numbered memory, right? If you say $1 is something and $1 here and $1 here, that means same string will be used in both the places, right? So an extended feature of regular expression is this: so the dot star er, they were, the $1 er, they will be. That means if you use one string for $1 as something, then that will be substituted here too. Okay, this is one gap. There is two gaps here. There are two gaps here. The $star here, they $star here. Then the first one has to be substituted with 1, and the second one has to be substituted with 2. Right? So there is substitution with memory. Substitution with memory. So memory is by using numbered registers by $1, $2, etc. regex is very important in NLP, in natural language processing. Why? When in natural language processing, you'll be using lot of text, and in a text you would like to search for different strings, substitute the strings, matching the strings, right? And what begins with which character, and so on. So it's a very powerful tool. Regex is a very powerful tool for shallow parsing, right? And for example, of very large corpora, you have big huge corpora, and in which you want to find what word is most likely to begin a sentence, right? You can give a particular regular expression and find out what word is most likely to begin a question. How often do people end sentences with prepositions, right? You can use regex and to find such things to use in large corpora. You also use statistical tool along with regex to find out the frequency, word frequency. What is a word which occurs more frequently in a particular text? In Shakespeare's dramas, what words occur very frequently? What occurs with what kind of word? Co-occurrence, right? Co-occurrence restrictions. So you can use statistics and regex together to find out what is the document about, what words typically modify other words. Like for example, politician. What kind of word you want to use with the word politician? Bad politician, good politician. Which word, right? What are the words which modify the words? Co-occurrence restrictions. These are called collocations, which we'll learn more about later. You can also use them in simple applications like ELISA. ELISA is a program which was done earlier, which interacts with human beings, right? You might have learned about this in other class, right? So you can build some applications like that. You can also find out how or who wrote Shakespeare's plays. Is it really Shakespeare or someone else? Depending on the writing, depending on the frequency of the words, depending on the kinds of words, right? Depending on the style, you can find out. That can be done using regex. You can also understand deception detection, that is statement analysis. And say, I am trying to be as honest as possible. Is he saying that he is honest? No. He's saying that means he's telling us that we know. Right? And as honest as possible. That means what is as possible? That also we know. He is not saying that how possible, how honest he is. Right? Such analysis, what we call statement analysis, can be done using regex. In fact, in your NLP courses, you'll be learning more about these kind of things. So, what we are looking at here is regular expressions, right? And then regular expressions are used to describe regular languages. Regular language can also be described by using finite state automata. In fact, you can use both regular expressions and finite state automata together to describe regular languages. Right? This is credited to Martin Kay. So Martin Kay tells us about this, that regular languages can be described using both regular expressions and finite state automata together. It's not necessary that only regular expressions can describe regular languages, or finite state automata only describe regular languages. Right? The three views come together there. Summary. What have we learned? We have learned that regular expressions are patterns that match with strings in a given corpus. They are the most useful tool for text manipulation. They are dumb. Why? Because whatever you give, they search only for that. They will not look for something else. They don't have that intelligence. But they are very powerful. They can search for a particular thing, however the corpus, how large the corpus may be, within seconds. Right? Here are actually all the regular expressions which you have seen. Okay. Thank you. We'll meet in the next video.